How are you doing? Good to see you.
Yeah.
He wants.
Oh, it's never missing another swamp.
Exactly. This is a good one. I didn't know it was in it, so not rolling those dice again.
But that's where, like, I do
It's not
think
super
that it's
crazy.
recorded,
Like,
and that's where
yeah,
we've
it's
been
a,
trying to make it so that we
it's not
can
super
switch
directional
people's,
or
like,
anything, so just kind of
clips.
get it on.
Yeah.
Because, you know, people are more into, like, short
And we
clips.
put
These
the
days, attention
super
spans are short. But it's like, hey, here's, like, a little short clip from the presentation to, like, see if you can post that.
I was thinking about
But
running
we
the,
haven't gotten around to that sort of stuff.
I was thinking about running it through that.
Themes
There's a thing that
and
Riverside or
automatically.
whatever.
Well, there's another one that does the clips.
Oh, okay.
And I was gonna run it through run a bunch of our presentations and make like YouTube and TikTok shorts.
We
To post to our
are
Instagram.
streaming show. Are you all just going to stand and talk, or
We can stand and talk, it's probably
do
easiest,
we
right?
want to? I haven't hooked in the clicker yet. Would you like to?
Yeah. Do we need the firm so that people think that I'm that comedian whose name nobody thinks?
Zach Galifianakis.
Think I'm Galifianakis? Wow, Zach Galifianakis really let himself go.
Maybe, I looked around, there are a lot of SaaS apps.
No. Okay. So he's going to do the intro.
Yes.
Yep. So he's going to do the intro. He's going to interview for a little bit. We'll take then just before you start, give me like 10 seconds to get it all set up so that you're showing the camera plus the
As long as you need.
slideshows in the background. And
There's
then
some
once I get it, so
precedent.
it's the slideshows are focused. I'll hand you the
I have that problem.
and then just go to the races. Okay.
Super.
Cool. So.
Producer, our executive producer Carl, it's on your go.
Turn on the camera.
Yeah, you're gonna have to tell us where the camera. Where's the camera even pointing?
I just don't.
Right, you're
The projector's pointing right here.
exactly. Yeah, you're welcome. You're welcome. Why don't you come over there? There you go. Go that, no, you can go that way. No, you're fine.
yeah.
I moved
Where do you
you.
want
I moved
me?
you by the fern. You're good.
Okay.
Okay. And the mic's on, so or the mic's now on. You're hot.
Yeah.
You're so hot.
He's understating it.
Beware
we
a
should get like
hot
clips
mic,
of
though.
we should get clips of Paris Hilton just saying that randomly. You're so hot. All right, we're good. Hey, everybody! Welcome to our almost weekly edition of Silicon Swamp. Thank you all for being here. We got a great big crowd. You guys can't see them. Let me hear like a raucous applause. For those of you joining us online, thanks again. We appreciate our virtual and in-person family here for the Swamp. We have a great speaker for you today. We have Dr. Eugene Callahan, who's works the professor at NYU, talking a little bit about giving us a historical perspective on efficiency in DevOps. I do not have any major announcements. Probably the big announcement that we'll just toss out for now, though there's going to be a little bit of debate about this, is we don't think there's any swamp next week. As far as we know, there's no Silicon Swamp. If that changes, we'll let you know on our Discord or all the other channels that we use to communicate with our multitudes. But just a heads up. So with no further ado, let me invite Dr. Callahan up to join us for a second and do our, as per tradition, awkward interview.
I'll be as awkward as possible.
Yeah, this is the whole point of this. Eugene, you prefer to go by Gene, right?
Yeah, usually.
Gene, I appreciate you coming to join us today.
I appreciate you having me.
We're excited about your talk. We'll just kind of go through and get a little background from you. So you are, just tell us a little bit about yourself. Where you're from, what you do.
Well, I was born in Connecticut. I was a software developer for many years, and then I went back and did some grad work and wound up teaching, but I still do development as well. My main focus in teaching is software engineering, agile, DevOps. I taught one of the first DevOps courses in the country at a university, as far as I know, because I looked, and one of the only, NYU is curious that we have 2 computer science departments, one in Manhattan and one in Brooklyn. Actually, we have more. We have one in Abu Dhabi, but 2 in New York City. And there was only one or two other courses, and one of them was at our Manhattan campus. So NYU was actually running 2 DevOps courses at a time when almost no one else was teaching even one. I really enjoy doing this stuff and enjoy teaching it.
How did you get into tech?
I was working as a forklift operator. I mean, the natural next thing was to become a computer programmer, wasn't it?
Yeah.
But PCs were hot at the time, and I said, this looks interesting. I had done well in logic in school, and I was a philosophy major. I took a logic class where everyone else was a computer science major.
Oh, okay.
Oh, that's interesting. It was in the philosophy department, but every other person, I think, in the class was computer science.
Okay.
And so I said, I guess I could get into this. And I actually got a job at tech support for a software firm that was doing managing your money, which is the hottest home finance package in the mid-'80s. You're smiling, you remember it?
Oh, I love that.
Yeah. And what happened was they were selling for $200 for the package, and some new company, Quicken, came out for $40, and the sales guy said, "We're number one. We don't need to pay attention to them." That was pretty much the end of that company. So I started in tech support, and the president said, "You're doing good at this. Why don't you start programming?"
What was the stack like back in those days? I mean,
so they wrote their own application language called Seesaw, which was written in assembler and C. The guys who wrote it apparently actually disassembled Lotus 1, 2, 3 and copied the spreadsheet. I had no part in that. When I got there, this was all done, but this is what I heard. And so basically, they ran a spreadsheet behind the scenes and had a way to put up a bunch of nice screens on it. So there was, basically assembler in C supporting a application language.
okay, that's cool. Well, I mean, you have a rich talk with a lot of advisory days, so I'll kind of move into like my normal final-ish question, which is, what things are going on in tech right now that you're particularly excited about, whether in software or rockets or any area?
I've had sort of been buried in the project I'm working on, but I think the whole agile DevOps thing is what's excited me the most in the last few years.
That's great.
Yeah.
Yeah, the last question before you kick off is, are you a questions during or a question after?
Oh, you can interrupt at any point, please.
All right, for the multitudes here in person and the ones online, I'll feed you any questions that come either on our Discord or our YouTube channel. Hit that like button, smash subscribe. Gene, the floor is yours. Our executive producer, Carl, will give you a signal when you're ready to go, but
Okay.
give him a second and then you're
By
off to the races.
the way, automated testing too. I've been focused a lot on automated testing, which part of the whole DevOps agile thing. But
It's definitely new, right? Like, in the grand scheme of things.
yeah. Okay.
Every week, Carl used to do this in front of everyone. Oh, we didn't talk about this. 2. But it sort of ramps up. Usually it's anywhere from like 2 to like 7.
But I think
If it's one, I still do my best.
Yeah,
I appreciate that. Doesn't matter.
And remember, we record these, so they're on YouTube forever for the millions of people that will find us.
And Paul had the most watched topic
What?
so far.
Yeah,
That's embarrassing.
yours is a very popular
Oh,
talk.
thank you.
We might have to do a redux of that. I want to do a redux of Brady's talk just because we didn't get a lot of people, and I think it was a really fun talk. And your talk was like people still keep telling us about it.
Oh,
So
man.
you're the star of the show.
What was the topic?
You go ahead.
I wrote a domain-specific markup language for formatted scripts for comic books,
Right.
So I'm a comics translator by trade, so I got to write a lot of scripts.
Uh-huh.
The hierarchical organization seemed to lend itself to that.
I like domain specific languages. I've written one full one.
No, I'm sure it was more involved than mine.
Yours was just like a really cool vibe of like, here's like a kind of very deep technical thing I did, mixed with a thing you wouldn't have thought of, like that you might be interested in. And it was just like a really cool way to show.
It does make for a good talk, I'll give it that.
Yeah, that's what I mean. It was a great talk. People had a blast with it. It was like a really fun one.
Well, and the cool part with yours specifically is that, because often if you're like a software engineer, you don't necessarily talk to customers, so you're just like deep in the tech.
Right, yeah.
And there's some benefits to that certainly, because you can, as a result, can get like really, really deep in some of the really technical things. But you're also like sometimes very far removed from the customer versus like you blend in the customer perspective where it's like, oh, I actually did. So you're sort of like the product manager and the software developer. You're the customer, but also the consumer. So it's blends a lot of things together.
Sorry.
No worries. Okay.
You have such a high stress job.
today. All right, so I should try to kind of get in front of the camera here, I guess.
No, you're good over there.
Oh, okay. All right, great.
There's plenty of time.
Okay, so this is actually an article published at Cutter IT Journal. They unfortunately have a paywall, but I have it. There's a link that I have for my class, and I can share that with people. So you can, this is written up in some depth for that article. But the basis of what I'm doing here is one of the people I studied a lot doing my PhD was R.G. Collingwood, and Collingwood said that you don't really understand a solution, an idea, until you know what problem it was trying to solve, until you know what it was addressing. So you can understand the theory of relativity, but you really have to understand the problems that Einstein was solving when he developed the theory of relativity to fully understand it. So the perspective I took here was to try to take a little walk through the problem space of what are agile and lean and DevOps a solution to, what's been going on. So we're going to go back to what did I do? I thought I.
Right.
Okay, hang on. Okay, hit the wrong button, I guess. So we're going to start, late 19th, early 20th century. And the model for how to do production was, assembly line work. This is the future. This is it's efficient. We can employ a whole bunch of people who we don't need to have them thinking at all. They're essentially a human machine. So what they can do is do some repetitive action over and over all day long, and they go, they get paid and go home, and they come in the next day and do the same thing again all day long. People came and took these jobs because it paid more than the alternatives they had, but I don't think many people really enjoyed them much. It's certainly, they were not stimulating. I worked on an assembly line, and I didn't find it very stimulating. One of the models here is that all thinking occurs at the top of the organization. So you have a factory, and what you've got is certain factory engineers and managers, and they are the ones who think, and they set up everything, and they employ a bunch of workers, and the workers' job is to do as they're told, basically. If the workers see some better way to organize the work, well, they probably are wrong, because we've got expensive engineers upstairs, and they organized it properly, so probably their contribution is not that important. This is so Adam Smith is famous for theorizing about the division of labor and talking about its productivity advantages. But he was not blind to the downside. So the great body of people becomes to be confined to a very few simple operations. The understanding is formed by their ordinary employments. The man whose life is spent in performing a few simple operations of which the effects are perhaps always the same, has no occasion to exert his understanding or to exercise his invention. He naturally, therefore, loses the habit of such exertion and generally becomes as stupid and ignorant as it is possible for a human creature to become. So Adam Smith did not think the division of labor was without a downside. When you get a few decades later, you get Marx talking about alienation. What he's naming there is the fact that the people have no connection to the product they're making. They're taking apart and screwing it on. We don't have to, embrace communism to recognize that Marx had valid insights, right? So it's not to say, hey, the Soviet Union, we should go, do that. No, but Marx saw things, right? He couldn't have attracted the followers he did unless there were some valid insights littered throughout his work. So, people have no connection to the product. They have no say in the quality of it, in whether it's an excellent product or a lousy one. They're told, screw this part on here and just keep doing that for 8 hours and then go home. Taylorism, Frederick Taylor is, he's doing academic research, theoretical studies, and determining the one best way to do things, and then the workers are going to be directed to do things that one best way. Taylor is, as in many cases, Taylor himself is better than Taylorism. Often, Marx is much better than Marxism, right? This is a common pattern. The original thinker is more subtle and more flexible than the followers. The followers take a simplified version and apply it. But, this you were going to have your work tightly constrained because your manager, who is also called scientific management, the scientific manager had decided exactly how you should do your job. And this is what you should follow because it was scientific, right? I mean, who can argue if it's scientific? Along with this, there was a very much of a push mentality, right? You're going to achieve great economies of scale by making a lot of whatever you were making. And it was going to be very uniform, very standard. Henry Ford famously said, cars are available in any color so long as it's black, right? So they were just producing one color car. And the model was to push this to the customers. So the job of the Ford dealers was to convince the customers that they wanted whatever Ford was making. So what we get is, as we hit the 50s and 60s, and corporations are going to be building software. This is something new to them. They're like, what? We have to, okay, look, computers obviously are important. We're going to have them. We can gain efficiency, but they haven't done something like this, right? This is something strange and foreign to them, and they're wondering, how should we do this? So it was kind of natural that the first thing they did was try to apply the factory model to making software. And we see this in the waterfall model. Again, I forget the name of the first guy who developed it, but he's better than his followers. He was much more flexible and didn't have this rigid of a model. But in the hands of his followers, it became a very rigid model. You put together a big requirements document. So I had one job that was very much waterfall, and they had, a big book of the requirements. And that was turned into a design document that was probably flow charts. And then the coders essentially had this place of the workers in the factory model. The analysts and designers, they were presentable people who wore suits and You could safely have them talk to business people. The coders had big beards and long hair and, you know, weird clothes, and you kept them tucked away somewhere. You didn't want to, you didn't let them roam around and, bother the customers. And then, of course, you pass that on to testing, and that gets passed to deployment, and that gets passed to maintenance. Important here is, so the intelligence is concentrated in the first steps, and the assumption is that we know, as we talk to the users, before we build anything, we know what the product is going to be like. We have a good idea of what we're going to build. Actually, so, you know, how do you know that? Well, you ask the customers, right? There's a few problems. Henry Ford recognized one of them himself. He said, if I asked my customers what they had wanted, they would have said faster horses, right? Steve Jobs said, the customers don't know what they want until I show it to them. And of course, the customers are giving him feedback. It's not that what he's going to show them initially is going to be perfect, right? But he's going to show it to them, and they're going to go, oh, this is great, except how about if we can do this, and what if we can do that? Another problem with this model is that since you're going to lock down the requirements, and then you're going to go to work for a couple years building the product, the customers have the motivations. I tell my students, let's say I told you you're going to go into this geodesic dome for 2 years, and you have to tell me everything you want because we're not opening the door for 2 years. What's going to happen? Well, they're just going to order everything, right? Anything they conceivably might need, they're going to stuff it into the dome because the door is not going to open for another 2 years. So, you know, a pallet of Twinkies, yeah, you know, just in case, right? You know, let's get it. So what you get is gigantic feature bloat, right? The customers are motivated to stuff in everything they can possibly ask for at the beginning. And what I saw in the one project I worked on that was very much waterfall, I got to the company and they said, okay, we're, you know, just a couple months away from releasing. And what we need to do for the next couple months, everyone needs to work extra, no vacation, work on Saturday, and, you know, then we'll release and we'll be back to normal. So this was going to go on for 2 months, and it went on for 3 and 4, 5, and finally I went to a guy who had been there a while, and I said, Bob, they said this would be likely 2 months, but it's been like 6 now. How long do you think it's going to go on? He said, well, I've been here 3 years, and it's been going on since I got here. So for 3 years, they had been on the verge of releasing the product and been, you know, saying, okay, all hands on deck. And what happened was they kept hitting terrible integration and testing problems. There was tons of bugs. The parts didn't work together. People hadn't understood the requirements because the requirements were done by people who talked to the customers, and the coders never talked to the customers. So tons of problems, right? Way of understanding what's going wrong. If we're going to build a new warehouse, and it's not, you know, a standard warehouse, it's not going to be a fancy automated warehouse, right? It's a big box made of concrete blocks with enough support that the roof doesn't collapse, and a whole bunch of racks, and if you need some refrigeration, or it's a, you know, freezer warehouse, you put in the appropriate things, cooling. And when Walmart needs a new warehouse, they're just essentially stamping out another copy of this thing. So you can plan that pretty much all in advance. You might hit something like, oh, this is actually a swamp. You know, like the Monty Python skit where the castles keep sinking into the swamp, right? We don't want to keep building warehouses that keep sinking. But there could be surprises, but pretty much you're just stamping out another copy. In software, if we just need another copy, we don't build anything. We just copy, right? When, you know, you need a copy of Microsoft Word, I don't start coding. You download a copy of Microsoft Word, right? So when we're stamping out something, we're not doing any construction at all. The only time we should be doing software construction is when we're trying to do something novel. Otherwise, get a copy of what someone already did. There's no point in starting coding. So the result of this, in many cases, was not pretty. Now, some projects can work this way. I think, for instance, if you're doing a Mars rover, you pretty much know what this thing is going to do. It's going to go to Mars and rove, right? Roam around, right? And it's going to pick up rocks and, you know, say, oh yeah, here's what this rock is like. Here's what this rock is like. It's going to take some pictures. The Martians aren't going to send us new requirements. The environment doesn't change. You know, there are things that could change, but it's pretty much a fixed mission. We know just what we want. So what, people recognize what's in the background of this image?
Vacuum tubes?
Yeah, vacuum tubes. So in the 1990s, what organization, should have said that, was the biggest consumer in the vacuum tubes in the world? They're buying them from ex-Soviet. By that point, the Soviet bloc had collapsed. But the only people still making them in quantity were in Eastern Europe, because they were still using computers with vacuum tubes. And
the U.S. traffic control?
Yeah, the FAA, Federal Aviation Administration, was the largest consumer of vacuum tubes. And why? Their big projects failed repeatedly to modernize the system. So they were still running on computers with vacuum tubes.
And they're still failing to this day.
Yeah, I haven't picked up on this lately. It's actually something I should follow up on. So, this is a nice page on Wikipedia. It's a kind of small, but I'll go closer and read it for you. The one thing that really puzzles me is the outcome. They have canceled, scrapped, and abandoned. And I don't know what the heck the difference between canceling a project, scrapping it, and abandoning it is, but they keep alternating the words, and I don't know if the person who made the table actually meant something different, or they just thought it was nice to have variety. So I'm not sure. But in any case, the second, and this table goes on a lot longer. It was already small enough. I didn't want to put anything else up. But here, from 1982 to 1984, the FAA spends $3 to $4 billion to modernize the air traffic control system, and it's was it scrapped or abandoned? It was scrapped. Okay, so it was scrapped, and it is, you know, just some absolutely horrific cost and time overruns. So this method was producing lots of disasters like this. And the one waterfall project I work with, I was there 3 years, and not a line of code I wrote ever made it into the hands of a customer. It was the worst job in terms of just grinding away and feeling you weren't doing anything, and like no satisfaction ever from you know, having a customer have their hands on your software. The most satisfying job, I worked at a trading company, and I was building options software, and I would literally walk out to the trading floor and say, you guys need anything? And they would go, yeah, could you put a little pop-up box that does this and shows us these numbers? And I go, yeah, okay, and I'd walk back to my desk, I'd program for an hour, I'd walk back out and say, okay, reload. And they would say, yeah, that looks good. And it was just such a world of difference between that and just programming away, feeling, you know, what Keynes said, that in a depression you could have one set of people dig holes and another set fill them. You know, that's what it felt like, right? You're just working for nothing, right? You got paid, but you know that's some motivation. But you'd also like to see your software used. Okay. So our story takes a turn now back to the world of manufacturing, and Toyota is interestingly very important in this story. It's just funny that a car company should show up as such an important role. So Toyota is looking at post-World War II. Japan is in ruins. It's a much smaller country, you know, population-wise than the U.S. And Toyota looks at the big American car manufacturers and says, we can't compete with them doing things their way. We have to have a different way of doing things. So Mary and Tom Poppendick. Mary Poppendick was a product manager at 3M. And they asked her to manage a software project. And 3M would produce, the product line, they produce little prototypes. And they'd play with the prototype and check it out and then say, yeah, this looks promising, go get me a new prototype. And they put her in charge of a software project, and she encountered the waterfall method, and she said, what? You guys develop products this way? Where's the prototype? Give me something I can see, I can play with. So they wrote a series of books, and this is an important quote. Toyota's real innovation is the ability to harness the intellect of ordinary employees, as opposed to what we see in the mass automation factory and in the waterfall projects. So this is very important. Toyota wanted to be very flexible. They developed in small batches. They tested continuously, did total quality control. Rather than a push method, they had a pull method, and so that work got pulled through the production line. And the dealers would tell the factories, here's what customers want. And because Toyota was flexible, they could pivot and begin making whatever that was. Because they worked in small batches, they hadn't just produced 1 million of whatever it was that they're making Corollas, and now they have to sell them. They have got to push them out. So they produced in small batches. The pull method shows up in modern software development as Kanban. So Toyota used Kanban boards, and what would happen was in the assembly line, you would pull new work. You would never, you wouldn't pile up work at one station until the next station needed it. And one thing this does is it minimizes defects, because if there's a problem, so let's say you're producing database routines and you're ahead of the API developers. Well, I'll just rush ahead. I should keep going. And you pile up a bunch of work, and then they say, you know, these don't work for us. This isn't going to be successful. We can't, you're querying the database every time. That takes too much time. You need to be doing caching. Now you've piled up a bunch of work with defects, and now you've got to change that work. So this is from Toyota. If you do a build and you're looking for the build to go green or red in GitHub Actions or whatever, CI/CD, Travis CI or Circle CI, that's from Toyota. They actually put up traffic lights. And whenever there was a problem, the light would go red, and the idea was you stop all production and fix the problem, because you don't know where back down the line the problem's actually coming from. There's no sense continuing to produce steering wheels if the problem is the steering wheel, the column doesn't fit into the assembly. I've never made a car, so I'm kind of shooting in the dark as to what kind of problems you might get, but things like that, right? This was a Toyota principle. Keep work visible. And the big thing, as Mary and Tom Poppendick said, was every employee was responsible for the entire product. Every employee should take pride in the car. Every employee should understand their part and how it fit into the entire car. And every employee was able to make suggestions about, what if we move the steering wheel production over there? Wouldn't that be quicker? Then we could deliver them here. And people would go, oh yeah, that makes sense. Let's try it. Another source, there's a little, okay, let me see. There's not sufficient disk space to continue recording. Is that that sounds like it might be a problem.
Wait a second. No, it's a real problem.
Told you not to be training them a lot of things.
Yeah, give me 1 second.
Well, I think it'll keep streaming, you just won't record.
I'll just delete something.
So I noticed that little thing pop. Oh, maybe it's Maybe it's saying something.
My
negative.
my bad.
Yeah, it's still streaming, so if you want to just
Yeah.
we can
Well, you take
Just
as
give me
long as-
1 second, and I'll
Take
just
as long as you need.
clean or
yeah, I'll just delete
I
some
hit
nonsense.
pause.
Do you need a drink, some water?
Oh, I got a tea here. Thank you very much.
Delete. This
Sit
should
down
feel.
past the shop. First time I found that. So
Did you stop by at the Japanese store, like here? in
yeah,
Brooklyn?
across the
First
The
house.
one that you had mentioned to me?
Yeah.
Okay.
Okay, I haven't been to that before.
It's a cute little.
You should be good to go now.
Okay.
And by the way, it's still recording on YouTube,
It is, yes.
which because it's not Twitch.
They
Okay.
burned us on the first one.
All right, so another
working
source
out.
of the transformation that happened in software development was the people at Bell Labs. They're actually the people who taught me how to program, not personally, I don't think I ever met any of them in person, but reading their books, right? So I consumed all their books, Kernahan and Ritchie and Thompson and P.J. Plowger and John Bentley, Programming Pearls and Programming on Purpose. And so I had absorbed this way of working, and my personal experience had shown me that the waterfall project just bogged down and was mired endlessly. But when I put out work quickly and got rapid feedback, I had really happy customers. The development went well. The releases were small. And I learned this from these Unix fellows because what they did was they put out a bunch of little tools, right? And one of the books says, 90% of what a customer needs delivered today is much more valuable than 100% promised next year, right? So they had the idea of a minimum viable product, right? They didn't call it that. They didn't call what they're doing agile. But this is why my background working with Unix and reading the Bell Labs people was why when I came across agile, of course I hadn't articulated, it's not like I had the whole agile manifesto in my head, but immediately I said, oh yes, this is a better way of working. This is how I have worked successfully, and when I haven't done that, it's been not so successful. Let's see. We're not advancing.
Yeah. Okay. Try.
All right. There we go. Again, Mary and Tom Poppendick developed lean software development. And 3M, right? You probably have heard how Post-it notes were developed. There was that accident, right? The person was trying to develop a very strong glue and developed a very weak glue instead. And then they said, oh wait, maybe there's a use for a very weak glue, and had a huge success. So she was in a background where you experimented, you tried things, you did prototypes, got them out rapidly. Decide as late as possible is one of the interesting things. And so I start my students off just putting the data that we're going to work. We're developing an API. We just put the data in memory. And I said, why? Well, we're going to delay deciding what our database is as long as possible. We can develop our whole API and not have a database. And what does that give us? Well, we can try out the API. The front-end developers can get going, because if they know what the interface is and you send them back data in the right format, they can develop the screens. It doesn't matter that the data is not coming from a real database. It's not the real data. But we delay that because maybe the greatest database in the world is coming out in 2 weeks, and we're going to commit to a different one, and we're going to be stuck with it because we invested a bunch of work in it and we can't switch. Empower the team, again, very important. That's kind of the overall theme of the talk. Agile was another stream feeding into this. Working software over comprehensive documentation. This is obviously waterfall, you produced a lot of documentation, and this was supposed to be an advantage. These documents weren't very interesting to read. they were not any guarantee that anything in the documentation would actually come to fruition, right? I was talking with someone who was working at a major bank, and I won't name the bank because I'm not trying to, make anyone feel embarrassed or anything. And this friend told me, she said, "Oh, we have this great new interface to Salesforce. It's a web interface. It's supposed to make it so much easier for us to work with Salesforce. It's going to be spectacular, and it's just available right in your web browser. And it's going to be done at the end of the year." And this was November. And I said, "Oh, that's great. How does it look? What they've been showing you so far? It's coming along nicely." She said, "What?" "Well, it's a web interface, right? They've been showing it to you all along, haven't they?" She said, "No." So what have they shown you? "Nothing." I said, "Yeah, you're not getting it in December, I would be willing to bet a lot of money that in December, you're not going to have a product. They had produced lots of documentation and statements of progress and PERT charts and Gantt charts, but they hadn't shown them any working software, right? And just my experience told me if they haven't actually shown them anything working, it's not coming through. She left the company, but she talked to someone 3 years later and said, "Yeah, we've gotten about 50% of what they promised us 3 years ago, December, so far." So this is, produce working software. The best documentation for software, I think, is the tests, because it's not that you need no other documentation, but the tests tell you how all the parts should work, what the return should be, what the failure conditions are, if you've written them well, and they have to stay up to date because they fail if they don't. So they have to change with the software, as opposed to the 500-page document on the shelf, which typically becomes out of date and stays out of date, right? Because programmers don't enjoy going and updating this monumental Word document. Okay, so these different streams are coming together and people are producing software faster. How am I doing for time, by the way?
Great.
15 minutes.
Yeah, super.
Hard stop.
We're reaching the end, so good. I just wanted to check in. These streams are coming together. You notice Mary and Tom Poppendick name it Lean Software Development and Agile Framework. So they know that they're working in the same area as Agile. But there's an issue. Operations people started hearing about we're going to release software more often, and their knees start knocking together, and they say, "I guess I picked the wrong week to stop popping pills." Right? They don't like this idea at all. Why? Because what their experience is, releases are awful. Releases make their life hellish for a couple months at a time. Their pagers go off at 3 a.m. And I've seen places where there was a big annual release. The first company releasing Managing Your Money, man, when we released, we would have a list of a couple hundred bugs, and we'd have to chunk through them, and we would there's going to be some intermediate release, but you got to wait for that. And as you fix these couple hundred bugs, you're inevitably making some new bugs, right? So operations ideal was can you just write the software once and then never release it again? Is that possible? That would be best, we think, because that way we just have this nightmare one time and then that's it. So when they heard, so this is the early 2000s, and people are talking about, there's an early Agile conference where this team said, we're releasing software a couple of times a week, and people were stunned. They were like, you're able to release a couple of times a week? But this really sounded to operations like this is going to be horrific, right? So if a yearly release has a month of problems, each
each bi-weekly release is going to produce a month of problems. And so we're just going to fall further and further behind, aren't we? So operations did not like this trend at all, for the most part. Some people, though, said, well, the developers are moving fast, maybe we can do something. So they asked the question, what if operations could become agile? Patrick Dubois was one of these people, and he organized a conference in 2004, 5, right around there. And he said, let's bring together agile developers and operations people who are interested in keeping up with the developers and seeing, can we become agile also? And he said, well, what am I going to call it? I've got developers, I've got operations, developers, operation. I'm going to call the conference DevOps. He just was naming a conference. He didn't know he was naming a trend, an industry trend, but it turns out he did. What came out of this was largely an application of agile tools to operations, to deployment, to monitoring. Interestingly, the very thing, Tom Lemonchili is the head site reliability engineer at Stack Overflow, or at least he was last time I talked with him. He might have moved jobs, but he said the principle is, if releasing software hurts, release it until it doesn't. So it's if you look at some of us may be aging a little, we might be getting more trouble touching our toes, right? So what can you do? Well, you could just say, oh, it hurts if I try to touch my toes, so I'm not going to do that. Or you can keep touching your toes until it doesn't hurt. The first method makes you less and less capable of actually touching your toes until finally it's just impossible. If you keep doing it, well, stay flexible longer, right? You're more likely to be flexible as long as possible. And this principle applies to releases. So in the early 2000s, there's a group saying, well, we're releasing a couple of times a week and shocking people. By 2013, Amazon was putting software into production every 11 seconds. Today, I tried to figure out what their rate is today. They're releasing new code into production more than once per second. And you notice, you don't see Amazon store crashing very much. You don't see, they have problems sometimes, but they're releasing all the time. Now, this is a huge number of developers. There's not one guy on lots of Ritalin who's like doing a release every second, right? It's this is across thousands and thousands of developers across a whole slew of products, right? But they are putting new code into production more than once per second, and things pretty much run, right? In fact, they run better. They don't get these huge backlogs because each release is tiny, right? So this is crucial, that you release each individual improvement, right? And you have a way that you have a pipeline where you can put out this, and you've got sufficient automated testing that if it passes all the tests, you're pretty confident you can put it out. You've got version control and the ability to roll back, so if there is a problem, you can roll back. You've got monitoring, so you'll know quickly if there is something that's gone wrong. And you work to not so that everything is so that you never have a problem, but so that you are agile. You can rapidly respond to problems. Are people familiar with Chaos Monkey? Okay, so generally, you've heard of Chaos Monkey? Well, so Amazon did crash April 21st, 2011. Amazon East crashed. And Etsy came down, and a whole bunch of big customers came down, and Netflix just kept running. And people said, oh, Amazon's giving them favoritism. But it turned out Netflix said no, and they released a white paper on Chaos Monkey. They had a program that deliberately just yanked servers down that were in production. And the goal was that any server could go down and they could keep running. And they said that's why we were able to keep running. When Amazon East went down, we had practiced this, we had drilled this, we had done this deliberately and found any problems so that if any part of our infrastructure disappeared, we should be able to work around it. Our system is flexible. It can adapt to the fact that this piece is missing. A key thing, infrastructure as code. I recall in the early 2000s, Microsoft was touting, you can set up a web server. You don't need to know all these configuration files and shells. You just point and click and get your web server configured. And it's so much easier. Anybody can do it. And the person who wound up doing Windows PowerShell, whose name I forget right now, took a job at Microsoft and said, you're still running the MS-DOS command shell. We should have decent shell. And they said, oh, we're Windows. What do we need? That's old-fashioned. You point and click to configure things. That was fine when companies were running a web server, right? When you're running multiple load balancers, fronting multiple web servers, fronting Redis caches and databases and credit card verification servers and a cutover data center offsite that you might switch to at any moment. You don't want to configure all this by hand, right? You configure with code now. And it turns out that configuring by hand is fine for a web server. Configuring with code, with configuration files, scales, right? You can't scale configuring by hand like that. So the final, the general theme of this talk is that what we've seen is a realization that we should be making use of the intelligence of all of the people in a workplace. They should all be contributing ideas. They should all be part of the quality of the final product. The title of the slide was a James Joyce quote, by the way. So Mary and Tom Poppendick, lean initiatives, agile DevOps, must be based first and foremost on a deep respect for every person in the company, especially the ordinary people who make the product or pound out the code. So what we've seen is an evolution of the division of labor, where we still have specialties. The structured agile project calls them generalizing specialists, whereas people, you need people who are intimately familiar with Python or React or your database, but those people shouldn't be mono-interested, right? They need to understand, okay, how do I have to configure the database so it works well with the Python code and serves the right stuff up to the React front end and meets the customer's long-term needs. So the people should be, they have their specialties, but they should be aware of the entire organization's operations and be conducting their specialty with an awareness of what's going on around them, rather than simply putting a screw into a hole repetitively all day long, and then not having no connection to the overall product. All right, that's it. I'm done.
I got one.
Oh, there you go. Kick us off.
answer is, I don't know.
Would you say that like the rise of DevOps as a discipline was sort of like the beginning of the end for the old school Unix sysadmin type, for lack of a better term? Like you'd have, at a school or a company, you'd have one guy or a handful of guys who, their office might literally be next to the rack of servers that
Yeah.
they worked on. That seems like that's pretty much not a thing anymore, and I'm wondering if that corresponded to this like new way of management.
Well, there are still roles for people who are basically keeping stuff running. Tom Limoncelli, as the chief site reliability engineer at Stack Overflow, like I said last I knew, he's also the author of the Unix System Administrator's Handbook, one of the 3 authors. So, I think what happened was the sysadmins, hopefully, the sysadmin role became less isolated and more, so sysadmins began programming more, and infrastructure as code was a big part of that. I was good friends with a sysadmin at Goldman Sachs in the aughts, and he said, "You do Python, I've got to learn Python." Well, they want me to program. He had done some shell scripting, but he knew a lot about starting and stopping processes and monitoring things and, a bit of shell scripting. But suddenly it was becoming important that you couldn't keep doing hand configuration because there were too many machines, right? So we used to go over, we would say we need a new database server. I guess, we're going to probably have it on its own box, and the sysadmin would order a new machine, and then he would know in his head, okay, I've got to do this, and I've got to set the permissions like this here, and I've got to, set this memory limit per process, and he'd do all this stuff by hand. And again, when you're doing a couple machines a year, you can do it that way. When you've got to bring up 100 servers, it's impossible, right? So the sysadmins learned that they had to automate this. Self-service is also a big thing. So you can go and just get a server, from AWS or Azure,
Sure, right.
or Python Anywhere. There's lots of places where, in a couple minutes you've got your own Linux server. But they have people doing sysadmin tasks to provide you with that. So I think the job has evolved, and it's not what it was 20 years ago. But hopefully people have been able to evolve with the new requirements, and those same people are doing what I would think is probably a more interesting job now. It's always more interesting to me to figure out how to automate something rather than slog through it by hand. If I can do it by hand in 20 minutes, or I could automate it in 20 minutes, I'll automate it. Because
over here, not playing the new Factorio release.
Go
ahead.
Well, and because then I can take advantage of what I did the next time the job comes up, right? So, and it's more interesting, right, to figure out, okay, still there's times where it's like, okay, right now I just need to enter these 5 parameters and get the thing running. What's going on here with Agile and DevOps is the changes with people's relation to work. The tools are great. I mean, there's a lot of good tools. People should learn them, but they're an age working this way, right? It's our altered relationship to our work that is the biggest change. That was kind of the theme of the whole slideshow, but I realized I didn't really talk about it.
Just a comment. I don't really have a question, but I think it's really interesting to me the way that this is evolving, and it's evolving, I think, in the way that it should be. Where you made the point earlier of saying that now everyone is responsible for the product, and the shift in these evolving roles are forcing everyone to be responsible for the product, and that's just going to be good for everyone and the customers, right, and the users.
Yeah, I mean, hopefully people don't have to be forced.
I don't think people do. I don't think people feel as though they're being forced. I think they're looking at it as it's an opportunity for me to expand my knowledge And as you say, I'm no longer doing something that's monotonous. Could you imagine just being a Unix admin and doing the same thing over and over and over? It's, how long is that going to be interesting?
Some people, their whole lives.
Do you have any and let me like like give some context for this. So I'm a little bit on the other side of the equation, right? Like my company Collide is focused on traditional operations, right? Like how do factories work? And so we're very familiar with a lot of this like Toyota production systems, and then of course we're also programmers, so we're very familiar with like agile and the new way. And then there's aspects of that we feed back into our communications with the industrial sector, right? But do you have anything that you feel like, in your opinion, like that you're sort of, you think agile does poorly or like gets overused, like things you don't like about agile?
Well, one thing which is misapprehension would be, people could easily get the impression, oh, agile, I just start hacking, right? I just, don't really need to do any design or thinking. I'm just gonna, I just get coding fast, right? So it could lead people to think that way. That's not, anything that any of the Agile Manifesto thing, but it is, it is tempting to just get coding. I see it with my students, right? Um, it's very hard to get them to stop, to realize, and I shouldn't be surprised it's hard, because it took me a damn long time to learn this lesson well myself, that if I'm not thoroughly tested on every step of the way, I shouldn't be racing ahead. One of my teaching assistants had a student come to them, a 200-line program, so there was lots of errors, and he said, okay, what was the last point where it was running properly? No, I just wrote 200 lines and now there's lots of errors. So it's very hard to convince them that no, write 4 lines and test it, and then write another 4 and test it, whether it's automated tests or you're just running the program by hand. But proceed in small steps, make sure each of them works. So people can misapprehend that it's just about racing ahead and coding as fast as you can. There's just as much design and studying your requirements are just as important. It's just that it has to be done iteratively, because you don't know everything at the start. That's the biggest issue. And you still have the problem if you get a customer and they want some product, we got a request from a government agency that said, well, we'd like to put, they were collecting it was inspectors going out looking at buildings and doing permitting and so forth. They said, well, we'd like to get some of this on the web to be available to our citizens. So please write up a proposal and tell us exactly how many weeks it will take. They don't know what they want. They want to get some stuff on the web. We didn't get anywhere because their process required this detailed statement of exactly what you're going to do. And so they don't know what they're going to do. If they were sensible, they'd say, let's start working together. We'll deliver you working software fast. And anytime you don't like it, you're not happy with what we're delivering, stop, cut us off. And the way their fear, of course, is that someone's just going to keep milking them for money forever. But if you work by delivering working software, and are you happy? Okay, we have a start, you like it, here's how much that cost you. Is that reasonable? Okay, let's keep going, right? So there is a mismatch between the way I think software can be most successfully developed. I saw it with the option traders. It worked. I went out, asked them what they needed. They gave me a sketch. I went back, did it, showed it to them. No, not quite that. Do this instead. I go back, redo that. And they go, yeah, that's good. So this kind of iterative, interactive development works fine. But there are large organizations have a real problem authorizing that, accepting it. So there's a mismatch there. I also think there has been an attempt, though I've read about this largely, right? I have not been exposed to it myself personally, but I see that a lot of people who were in Agile early are complaining that it's been turned into a bureaucratic process. Now there's, you have to do these tickets and track your story through each step. And
Your T-shirt sizes. That's how you keep track of your stories. T-shirt sizes. That's one of them.
Yeah. So that the very thing the Agile Manifesto was trying to avoid has been the managers who want to process that they can put in the PERT chart and tell you it's going to be 7 months and we'll deliver it, have kind of captured Agile and made it more bureaucratic. As I said, I haven't personally worked in a situation like that, but I've heard a lot of complaints out there. This has happened.
I think that's the only way I've seen Agile done.
Yeah. To me, the real Agile is I would go talk to my customer. What do you need? And I go code it and come back and say, do you like it? Oh yeah, great. And these were people. This was not. They were trading millions of dollars, a day, right? So these weren't people who were just like, we're just clowning around. We don't care if the software really works, right? This software had a serious use, and this is the way we developed it. And I was happy, they were happy. The product evolved very fast.
Do you have any concerns about how a lot of Agile development has a tendency to start iterating towards like being more robust, which decentralized systems inherently are more robust, which means like they're easier, more adaptable, changeable, but less efficient. So for just to like give a pointed example, right? Like generally, like as you start doing Agile development, you start saying, how do we structure the code so that more and more people in our software team can easily make changes that aren't going to bring the whole thing down? And then generally you start heading towards something that looks like a microarchitecture, right? We have like little instances and then you start putting together. And then by the time you're done your Netflix, and then you realize, oh, a monolithic code is like 20 to 30 times more efficient than our crazy microarchitecture.
Well, we had real performance requirements in the option trading situation. Now, that happens, no doubt, but here you've let people have let the requirements of what their customers need slip away and embraced an ideal of this componentization that we're going to do this software the perfect way and everything's going to be a little microservice, right? And they've lost track that customers need the speed. We were able to we had multiple components, but we're able to do things really rapidly. We were getting price feeds from 4 different exchanges. And based on the changing prices, we had to update a bunch of theoretical values. So we knew that these people needed them updated sub-second. And so what we designed was a system where we had a math PhD who's doing the option modeling. And overnight, he would run a big batch job on a rack full of computers that produced giant tables for each option. And the tables were interspersed theoretical values based on different prices. And then in the morning, I would read the tables. And as the prices changed, I would just interlope value, right? So we had theoretical values over a $10 range, just do linear interpolation.
A big like lookup table essentially with some
So
interpolation.
we didn't need to do the calculations. Never could have been run in real time. We never could have kept up. Calculations ran overnight, and we loaded a table with 10 values and then interpolated between them, and that way we could get the values really fast. This component-based system could be used for speed if we understood, okay, the need for speed is real here. We're actually separating the calculations from the front end. And because we've done that, we can get the front end performance much, much faster than if we tried to do the calculations on the front end. So, a component-based architecture doesn't have to, if it's designed for speed, I don't know why. But you should be able to do something like that. Dave Farley does a lot of YouTube videos, and one of his big projects was cutting-edge stock exchange. And he's very much into modularization and narrow interfaces, loose coupling. He wrote modern software engineering, continuous deployment, continuous delivery. That's humble. So he embraces these ideas, but they were able to use them to write cutting-edge electronic stock exchange. So I think when it bogs down, people have lost track. They've embraced an abstraction as opposed to focusing on what their customers really need.
You like with their original 500-page requirements, which would have had all that. No, I'm joking. No, it's interesting to hear because we've been on both. I've been on both sides of this. Like we did agile in an FDA environment. That was interesting. Any other questions before we? We're about that time. All right. Hey, Dr. Callahan, thank you so much.
Now I'm going back to write a comic.